Yeah, hi. Yeah, good afternoon to everyone. In the last class, you learned about the transaction. Transaction means it can consist set of operations. The set of operations when you are performing in the single task, we are calling as a transaction. Now, coming to under the transaction, in the previous class, you learned about the operations. Then read and write operations you learn about the under the transaction. Then some of the about operation and the commit operation, the rollback operations you learn based on the at the time of you are performing the task under the transaction. If you are getting as a failure, for eliminating that failure purpose, you went for the properties, acid properties, atomicity, consistency, isolation, and durability. The, in the today's class, you are learning about schedule. Under the DBMS, we are having the schedule and testing of serializability and conflict serializability schedule we are learning in the today's class. Now, coming to what is schedule. Under the DBMS, schedule means a series of operations from one transaction to another transaction we are calling as a schedule. Means if you want to perform the series, means actually the series means it's a sequence. The sequence operations when you are performing from one transaction to another transaction we are calling as a schedule. Yes, it is used to perform the order of the operation in each of the individual transaction. For example, if you are taking as a T1 is a transaction, under the T1 transaction when you are performing the operation, after performing the operations, then the transaction it is transferring to the another T2 transaction, means sequence one after the another. A series of operation from one transaction to another transaction we are calling as a schedule. Under the schedule, it is categorized the three types. Serial schedule will be there. Serial schedule means it is sequence one after the another. Serial means in order format. After executing the one transaction, then only it will execute to the second transaction. At that time, we are calling as a serial schedule. Coming to non-serial schedule means it should be in format of random. Means under the T1 transaction, it will perform some operations, then it is executing to under T2 transaction of the operations. Only some operations it is executing under T2, entire operations it is not performing, then it is going to the T2 operation, it is performing the action, then we can call as a non-serial. In the meaning only will be the serial means one after the another. Entire the under the T1 transaction, when it is performing the operations, after performing the entire operation, then the schedule goes to the second transaction, T2 transaction, then we can call as a serial schedule. Schedule under the DBMS it is categorized three times: serial schedule, non-serial schedule, and serializable schedule we are calling. Now coming to the what is serial schedule. Serial schedule means it is a type of the schedule where one transaction is executed completely before starting the another transaction. Just now I said serializable schedule means after completing the entire the task under the transaction, if you are having the n number of operations, after performing the n number of operations entire the task, then only it should execute under the T2 transaction, then we can call as a serializable schedule. Serializable schedule is a type of the schedule where one transaction is executed completely before starting the another transaction, then we can call as a serializable schedule. In the serializable schedule, when the first transaction is completes its cycle, then the next transaction is execute. Here the cycle means operations. If you are under the transaction, it can consist n number of operations. After completing the entire operations, then only it should execute the next transaction. Means here completes its cycle, means under the transaction operations, n number of operation or tasks performing only, then it should be execute under the next transaction or second transaction. If you want to take the example for your understanding for the serializable schedule, under the serializable schedule we are taking the two transaction, T1 transaction and T2 transaction. T1 and T2 have some operation. Just now I said T1 it can consist n number of operation, and T2 it can consist n number of operations. Now under your example, T1 it can consist some operations will be there. Under this operation, no interleaving of operation, then there are the following two possible outcomes will be there. If it is as no interleaving of the operation, no interleaving means at the time of the executing the transaction under the T1 it should be perform entire the task. No interleaving of the operation means after completing the task or the work only, then it should go to the second transaction. Execute, maybe if you are taking the two possibilities, if you are taking under your example, all operations of the T1 which as followed by the all operations of T2, means here we are taking the scenario, two possibles will be there under the T1. Under the T1, all operations of T1 which follows by the all operations of T2. Then under the T2 and T2 also reverse, it execute all operations of T2 which followed by the all operations of T1. Means no interleaving of the operations will be there. If there has no interleaving means in T1 if you are having 10 operation, under the T2 also 10 operations, means here the equal operations will be there, means it should be the execute the first T1 transaction, then only it go to the T2 transaction. Maybe your understanding purpose I am taking the one clear understanding purpose I am taking the diagram or the figure. Now by seeing this figure, under we are having two diagrams will be there. Under the two diagrams, serializable schedule where T1 followed by the T2. Now here also under in this diagram, if you are taking that serializable diagram, this is example for based on that example I am taking as a diagram T1 and T2. Now in the last class you learned that transaction means it can consist set of operations. That set of operations we are performing under the single task we are calling as a transaction. Under the transaction we are having the two major operations will be there, read and write operation will be there, reading and writing purpose. These are the two operations will be there. Means under the T1 transaction, A is a person. Under the T transaction, it is reading the content. Under the A content means, if for your understanding purpose, I am taking as a banking application. I am taking as a banking application. A1 is a customer. The customer having the so and so amount will be there. It is reading from the database. At the time of it is reading from the database, means from the T1 transaction, maybe from T2 transaction he was transferring the amount. Means when he was transferring the amount from the T1 transaction to T2 transaction, under the A account the amount should be deducted. That is the purpose we are writing the condition. A means A minus N, means some N is a value, some value, maybe 10,000 or 20,000. Means after transferring to the T2 account, then we should get the balance. What are the deducted amount is there, then what is the remaining amount will be there, then it should be available. Then after that, under the T2 it is having as a B. Now under the B, what is the amount you transferred from the T1 from the A account to the T2 account of the B? What are the amount you transfer from the T1 account of the A person, that amount should be the visible to the A account. Means if you are taking as a banking account, maybe under the banking if you are taking as a mini statement, under the mini statement from the current amount, maybe it is the amount is deducting, then we are getting the balance amount. So and so amount is transferred to some other person, we are getting as a best example for your mini statement for the banking, or maybe in the YONO mobile app also for SBI. If you are taking from the any banking application of the mobile apps also, we can see the mini statement. Means when the amount is deducting from the current account to the, when it is crediting to the some other account, maybe when you are getting as a minimum balance, it is a scenario of the serial schedule will be there, one after the another. Means again it is writing here, means what is the balance amount will be there, again it is writing under T2. Means under the T1 we are performing deducted amount, again the credited amount, from the credited amount of the other transaction also we are getting, then reading from the B, and next we are going for the transaction of the B2. Means it is performing the entire task. After performing the entire task under the T1, then only it is going to the T2. Maybe your understanding purpose, A is a person, A is a Ravi. Ravi having the in the account 50,000 rupees will be there. From the A is a Ravi, B is a Rupesh will be there. T1 is a transaction. Under the T1 transaction, we are having the n number of operations will be there. Just we are having only for 1, 2, 3, 4, 5, 6. 6. Just consider as a 6 statements. I am considering as a 6 operations. Now under the T2 I am considering only the 3 operations. Now coming to the serializable schedule, under the T1 transaction, A we are considering as a Ravi person. Under the T2 account, B is we are considering as a Rupesh. Now from the A account may be considered as a 50,000 rupees will be there. From Ravi account, when he was transferring to the amount to the Rupesh account, now the amount is deducting. That is the purpose we are performing the task or the operation A minus N. Means A 50,000, suppose I am transferring as a 10,000 rupees. Means 10,000 rupees we are transferring from the A account to the B account. Now after when you are transferring, then we should get as a balance. What are the remaining amount should be there? The remaining amount we are getting as a 40,000. Means from the 40,000 of the Ravi account only. Now again we are reading from the B account. Means from the B account, maybe some example, maybe if you are having as a 5,000 rupees. Then from the B account, 5,000 plus 10,000 we are having 15,000. Means under the serializable transaction, under the serializable schedule, we are performing the entire task in sequence order. After performing only, then we are going to the second transaction. From the second transaction, it is reading. See a reading of the A account. What is the debited value? 1,000 rupees. 1,000 plus 5,000 means we are getting as a final, we are getting the value as 15,000 rupees. Maybe your best understanding purpose for the serializable, I have given here the diagram. A should as a serial schedule where T1 follows by the T2. Means under the serializable transaction, T1 should follows by the T2. Means under the T1, it should execute all operations. After executing, then only it should follow to the T2. Then only we can call as a serializable transaction. Now one more example is there for your understanding purpose. Maybe it can execute under the T2 transaction is a first. After executing the T2, then it is coming to the T1. See here. Maybe it is not a rule. Now I given here in the diagram where T1 follows by the T2. In the second diagram, T2 is followed by the T1. Means it is not a rule. Which transaction is executing the first? It is not a major rule under the serializable schedule. As per your knowledge, from if you are transferring from the T2 account, it is okay. Means we should consider as it from T2 account we are transferring to the T1 account. From the T2 account, we are transferring to the T1 account. Means it is a reverse. Means the transaction should be execute maybe under the T1. After executing the entire in the schedule format, then only it come to the T1 transaction. Then we can call as a serializable schedule. Coming to the non-serializable schedule. Schedule it is categorized as 3 types: serializable, non-serializable, serialized schedule. Now we are going for non-serializable schedule. Under the non-serializable schedule, interleaving of the operation is allowed. Then there it will be non-serializable. Interleaving. The term in the previous, no interleaving operation. No interleaving operation means It is not a random. Here interleaving operation will be there under the non-serializable schedule will be there. Interleaving of the operations is followed. Means interleaving means under the T1 account, see here, randomly. Under the T1 account, this is the one operation, this is the second operation, this is the third operation. Just we consider as a read operation. After reading, it is performing some task. After writing and reading, 1, 2, 3, 4 operations will be there under the T1. Under the T2, we are having only for the 2 operations will be there. Under the T1, we are having as the 4 operations. Under the T1, it is not performing the 4 operations. Under the non-serializable, it is performing only up to 2 operations. Then it is going to the T2. They we are calling as a interleaving of the operation. Means entire under T1 transaction, it is not performing the all operations. When it is not performing means we can call as a non-serializable schedule. It can consist many of the possible orders which may the system can execute individual operations of the transaction. Coming to the non-serializable schedule, under the non-serializable schedule means the system it is executing an individual operations under the T1 and T2. It is not performing under the sequence order. Then if it is not performing means we can call as a non-serializable schedule. Maybe if you are understanding purpose, I took as a 2 diagrams or figures C and D. Under the C, according to the C diagram, if you are taking as under the T1, see here it is executing. Under the T1 it is executing the read operation. After executing the read operation, then it is going to the T2 read operations. Means non-serial. Means serializable schedule means under the T1 transaction it should perform all operations under the T1. After performing, then only it should go to the T2. Then we can call as a serializable schedule. Coming to the non-serializable schedule means under the T1 if you are having the n number of operations, among the n number of operations it is performing one action. After performing, then it is going to the T2 transaction under the another operation. Means it is not executing the entire all operations under the T1. Means this is a T1 transaction, T2. Under the T1 it is performing one operations. After reading the one operation, then it is going to the T2. Under the T2 it is going to the another operation. Means the remaining operations it is not performing the action. After performing under the T2, again it is coming to the T1. See here, one after the another. It is not going for the one after the another in the sequence order. Means under the T1 it is performing one operations. Then it is not executing to the second operation the T2. Then it is going to the T1. Under the T1 it is executing the another operation. After executing the T2 another operation, again it is not going to the right operation. Then it is coming to back again to the T1. Means here we are having as a cyclic scenario will be there. There the cyclic scenario will be not there. Non-cycle will be there. Here cyclic scenario will be there. Non-serializable. Now coming to under the D diagram also for the non-serializable. Now it is performing the T1. After performing the T1, then it is going to the T2. Same scenario will be there. Just here only the one operation will be there under T2. Under the T1 we are having as a 2 operations. Now according to this diagram, the best example for the serializable is the A and B diagrams is the serializable diagram for the schedule. For C and D will come under the non-serializable. Coming to the serializable schedule. Serializability of the schedule is used to find non-serial schedule. The main duty of the serializable schedule used to find the non-serializable that allow the transaction to execute concurrently without interfering with another. Means the transaction should execute concurrently. Concurrently means parallelly without interfering to the another. Means concurrency means parallelly it should be execute. Means under the T1 and T2 concurrently it is occurring means it will occur as a deadlocks. That is the purpose they implement as a synchronized concept. It is identified with schedules are correct, then the execution of the transaction as interleaving of their operations. Non-serial schedules will be the serialized. If it is result is equal to the result of the transaction is executed serially. When we are calling as serializable means non-serial schedule should be the serialized if it is a result is equal to the result of the transactions executed serially, then only we are calling as a serializable. Now if you how you are testing for the serializable, if you want to test the testing of the serializable, we are having as a serializable graph. With the help of the serializable graph we can test your serializability or serializable. Now if you want to test your serializability, we are testing with the help of the graph. Now if you are taking as a schedule is a S, schedule is a S. If you want to construct a graph, we are having the vertices and edges. Graph it can consist pair of graph if we are representing with the help of the G. G means the graph it can consist vertices and edges will be there. G equals to graphs and edges. If you want to assume for the schedule we are considering for S. If you want to construct the graph, for the graph we are proceeding with the help of the graph. The precedence of the graph we are representing G equal to V of G, where V it can consist set of vertices, means E it can consist set of edges. A graph it can consist vertex and edges will be there. The set of vertices are used to contain all the transactions participants. Means if you are representing as vertices, if you are representing as a V, all transactions should be participate in that schedule. If you are representing as a vertex, as per your understanding for the serializability, if you want to test for the serializability, if you are representing as a node as a V, then by representing that V node, it performing the all transactions. It should be the perform the all transactions. Then if the set of edges it contains all edges, T of I representing as a Tj, means Ti is pointing to Tj. For one of the three conditions it follows. Means if you are creating as a node Ti, Ti is pointing to Tj. If the Ti is pointing to Tj, Ti is execute. Ti is executing with the help of the write operation before Tj execute read. Means if you are representing as Ti is pointing to, if you are representing as a node, the node is Ti is representing to Tj. Tj is execute, when Tj is executing the write operations, before the Tj it should be execute read operation. Means before writing the write operator, before executing the write operation, before executing the read operation, the write operation should be execute. Means here when the Ti is pointing to Tj, maybe it is parallelly it is executing the write and read operation. Before executing the read operation, it is executing the write operation. Now if you are representing the node Ti is pointing to Tj, if Ti execute read operation before executing the write operation, means here the reverse will be there. Write operation and read operation will be there. The read operation should be execute before. Before the write operation. The write operation should be execute before the read operation. When it is Ti is pointing, here we are having as a three conditions will be there. If you want to execute the read operation, before only it should be execute write operation. If you want to execute the write operation, before only it will be execute the read operation. Here vice versa will be there. Now when it is creating the node of the Ti is pointing to Tj, Ti is executing the write operation before executing the write queue operation. Means Here the three conditions will be there. Maybe here the two conditions, maybe you can understand. Before executing of the read operation, the write operation should be executed. Before executing of the read, before executing the read means, for example, T1 and T2 will be there. Under the T1 write operation will be there. Under the T2 we are having as a read operation. Before the read operation, before executing the read operation under T1, you should be execute under the T1 write operation. This is the first condition. Coming to the second condition, under the second condition, under the T1 is the read operation will be there. Under the T2 we are having as a write operation will be there. Here we are taking as a vice versa. Under the first condition, T1 is a write operator will be there. T2 we are having as a read operator will be there. Before executing the read operator, first it should be the perform the write operation. Coming to the second condition, under the T1 read operation will be there. Under the T2 write operation will be there. Before executing the write operation, it should be the read. It should be the read the operation from the T1 transaction. Second condition. Coming to the third condition, it should be the execute. Suppose if you are having under the T1 and T2, if you are having the write operation and write operation, T1 write operation, T2 write operation will be there. Before executing the T2 of the write operation, before it should be execute the write operation under T1. These are the three conditions will be there. With the help of the three conditions, we can test your serializability. Now, if you want to represent the graph under the schedule, maybe we are representing with the help of the precedence graph. Here the precedence graph it can consist as a single edge will be there. Means E we are representing as a node as a edge. Ti is pointing to Tj. Means here the edge will be there. Ti is a one node, T2 is another node. From edge is pointing to the another edge. Ti is a transaction. Ti is a transaction. The single edge it is pointing to the Tj of the transaction. Then all the instructions of the Ti are execute before the first instruction of the Tj is execute. See the condition. Under the preceding graph of the single edge, under the Ti are execute before. Ti should be the execute before. First instruction of the Tj is execute. Before executing the Tj, before it should be execute the first instruction under the Ti, then only it should be the go for the Tj transaction. The precedence graph for the schedule is S consists as a cycle. Then S is a non-serializable. If the precedence graph for the schedule is consists as a cycle, then we are calling as a non-serializable. Just now I said serializable, non-serializable. Now if the precedence graph has a no cycle, then we can call as a serializable. If you are not having the cycle, then we are calling as a serializable. Non-serializable means if you are having as a cycle, we are calling as a non-serializable. If you are having the circles, n number of circles if you are having means we are considering as a non-serializable. Coming to the serializable means it does not consist the cycle. Now if I am taking as an example, now here the T1 and T2, T3 are the three transactions on the schedule. This we are the three transactions we are considering as a one schedule. T1, T2, T3. Under the schedule we can take n number of transactions. Now your understanding purpose, just I am taking only for the three schedule under three transactions under the single schedule. Now under the T1 transaction we are having as a read operation, write operation, read, then write it is performing. Coming T2 we are having read, write, read, write, read, write, read, write, means same will be there. Now under the T1 it is executing the read operation first. After executing, then it is going for the read operation under the T2. After executing the T2, then it is going to the T3. Means the entire operation it is not performing. Means one after the another, it is not sequential, it is not executing under the T1. Under the T1 the first instruction is executing. After executing the first instruction, then it is going to the T2 transaction of the first instruction. After executing the T2 transaction of the first instruction, then it is going to the T3 transaction of the first instruction. Now see here, means it is of one after the another instruction of the transaction is executing. Under the schedule, it can consist n number of transactions according to your purpose. Just I am taking only for 3 transactions, T1, T2, T3. Now the first instruction under the T1, coming to the second instruction, this is the third instruction, first instruction under the T1, first instruction under the T2, first instruction under the T3. Now maybe entire operations it is not performing. Under the T1, maybe if you are having the n number of operations, maybe 4 operations or 5 operations will be there. Under the T1, first operation or the first instruction is executing. After executing, then it is going to the T2 transaction of the first instruction or first operation. Means under the T1, after executing the first instruction, then it is not going to the second instruction. It is not going for sequential. It is after one after the another, means sequential. Means first it is reading from the T1, it is reading from the T2, it is reading from the T3. After reading, then again it is coming to the, where it is coming from the T1, it is performing the one more operation is there. Under the T1 it is performing the, under the T1 it is performing the operation, it is going to the T2 the first instruction, that is going. Now it is coming to back from the T2, then it is writing. After reading, then it is writing the value of the A. Maybe a simple understanding purpose, I given the explanation here. In T1, no subsequent writes to A, so no new edge is there. In the T1, no subsequent. Subsequent means after instance, after next, after executing the first instruction, second what will be there? Subsequent. Subsequent means under the under T1 read operation will be there. After the read operation, the subsequent operation of the instruction is going to the T2. Here also I given, it is reading. After reading, it is reading the function A under the T1. In T1 it is reading the read operation. No subsequent writes to A, no edges will be there. When it is performing the action under the read, no subsequent to write is there, no edges will be there. When it is reading the second transaction, under the second transaction and the T2 transaction, when it is reading, no subsequent write is there to the B, no edges will be there. Coming to the C also, under 3 transaction C, no subsequent will be there, no subsequent to C, no edges. Means subsequent means after. After T1 transaction, what will be there? Here no subsequent will be there for the read operations. For read A operation, read B operation, read C, these 3 operations is available under T1, T2, T3. Subsequent will be not there for read operation A, B, C, even edges also not there. When you are writing as a write operation under the B, when you are going for the write operation under the B, see here, B is a subsequent read by the T3. When it is performing the B operation, the subsequent will be there, 3 will be there, T3 transaction will be there. T3 transaction will be there. When is B is subsequently read by T3, so at the edge of T2 is pointing to T3. See here. When if you are having as a subsequently after, when it is for the write operator, we are having the T3 transaction will be there. After the T1 we are having as a T3. That is the purpose. B is subsequently read by T3, so at the edge of T2 pointing to T3. Write C. Write C is subsequently read by the T1. Means after C it is subsequently read by the write operator under T1. C is subsequently read by the T1. So the edges of the T1 is pointing to the T1. T3 is pointing to the T1. Now when it is writing operation, A is subsequently read by the T2. So the edges is T1 is pointing to the T2. Here the cyclic will be there. Here cyclic is existing under the in this schedule. Under the S1 schedule, T1 is pointing to the T3, T3 is pointing to the T1, T1 is pointing to the T2. Means sequence will be there. Now, when it is going for the T2, no subsequent is read by A, no edges will be there. Under the T1 also no subsequent will be there, no edges will be there. Under T3 also. Now under the S1 schedule, it is occurring as a cyclic. Then when it is occurring as a cyclic, what we can call, just now you learned about, if you are occurring as a cyclic. For the non-cyclic, for the non-serializable means if you are having as a cycle, we are calling as a non-serializable. If you are not having as a circle, we are calling as a serializable. No cyclic it is formed. Non-serializable, by testing your schedule, when you are testing the schedule, now we are calling as a non-serializable. Non-serializable means when it is forming as a cycle. If you are having the number of cycle, we are calling as a non-serializable. T1 is pointing to the T3, T3 is pointing to the T1, again T1 is pointing to the T2. Means it is occurring as a cycle, then we are considering as a non-serializable. The preceding graph of the schedule S1 consists as a cycle. Means T3 is pointing to the T1, T2 is pointing to the T1, T1 is pointing to T3. This it is occurring as a cyclic, then we are calling as a non-serializable. As for your testing as a schedule, T2 is pointing to T3, T3 is pointing to T1, means T3 is pointing to the T2. T3 is pointing to the T2. Then T3 is pointing to the T1. T3 is pointing to the T1. T2 is pointing to T1. T1 is pointing to T3. T2 pointing to T3 pointing to T1. Actually it is, I did the mistake here, the arrow representation. Now if you are going for the one more example for the schedule 2, under schedule 2 we are having T4, T5, T6 transaction will be there. Under the schedule means here under non-serializable it is performing, it is not executing the all operations at a time under the transaction. It is performing the some operation under T1, then it is going to the T2. Coming to the serializable, it is performing the entire operation, or it is executing the entire instruction at a time. Then it is going to the T5. Means here cyclic will be not there. Under T4, T5, T6 we are taking as a schedule 2. Under the schedule 2, T4 transaction, it can consist n number of operations or n number of instructions. It is executing the all operations. After executing, then only it is going to the T5. Sequential will be there. Now in T read, if you are taking as a read A under T4 read operation, no subsequent writes to A, no edges will be there. If you are taking as a read operation under T6 transaction, no subsequent write is there, no edges will be there to C. No subsequent will be there for A, no subsequent will be there for A, and no subsequent will be there for C when it is reading for the C operation. Now when you are going for the subsequent for the T5, T4 is pointing to the T5 with the help of the edge, T4 and T5. T4 is pointing to the T5. After completing only it is pointing to the T5. Now with the help of the read operation under the transaction 5, under the transaction 5, when you are reading the transaction 5, no subsequent will be there for the B, no edges will be there. Means edges will be there, not there, no edges, no subsequent will be not there for the transaction 5 at the time of your reading. Is there anything? Here the empty space will be there for your understanding purpose. No subsequent will be there. Subsequent is when it is reading A is a subsequent, when it is A is a subsequent, then it is reading the T5, no edges, so edges is T pointing to 5. When it is reading the T5, no subsequent. When it is reading the T5, under T5 when it is reading, no subsequent before or after. Now when it is reading the transaction, when it is reading the write operation under the transaction 6, no edges will be there, so edges it is T4 is pointing to T6. Then subsequently when it is reading the transaction 6, edges is pointing, T5 is pointing to the T6. Similarly, all operation in this way only if you are taking for the preceding graph from your schedule 2, T5 is pointing to T6, T4 is pointing to T6. Means here the cyclic will be not there. Cyclic is not there. Then we can call as a serializable. T4 is pointing to the T6, T4 is pointing to the T5. Again T5 is not pointing, T5 is pointing to the T6, T5 is not pointing to the T4. Then we can call as a serializable. Now when we are calling as a conflict serializable, when we can call as a non-conflict serializable, very important. Serializable also very important. Serializable means in sequence, cyclic will be no cyclic is there, means we can call as a serializable. Non-serializable, if you are having as a cyclic format, we are calling as a non-serializable. Coming to the conflict serializable, under the conflict serializable, when we schedule we are calling as a conflict serializability. If after swapping, then only we are calling as a non-conflicting operation. Non-conflicting operation means same operations it is not performing, we are calling as a non-conflict. It can be transforming into the serial schedule. It can be transformed. Schedule when you are calling as a conflict serializability, after swapping from the one conflict operation, then we are calling as a serializable schedule. The schedule when will be the conflict serializable, it is non-conflict equivalence to the serializable schedule. Under the conflict operation, we are having as a two operations will be there. It will a separate transaction, it should be execute. Both the transactions should be execute the separate, maybe have the similar data, maybe it can consist only one write operation. At least one operation should be there under the conflict operation. Two operations become the conflict. When it is becoming as a conflict means when it is consist only the one write operation, it is having as a similar data, it is having as a separate transaction is existing, we are calling as a conflict operation. Now if you are understanding purpose for the non-conflict and the conflict, when we are swapping S1 and S2, when we are swapping, S1 is a schedule and S2 are the schedule, are logically when we are swapping the S1 and S2 are both are equally, then we are calling as a non-conflict. S1 equal to S2 means under the S1 schedule, if you are having the two transaction or n number of transaction, under the S2 schedule, if you are having the n number of transactions or only two transactions, if you are having only for the two operations, now see here, under the T1 transaction read operation will be there, under T2 also we are having as a two operations will be there. Means when we are swapping, means S1 equals to S2, then we are calling as a non-conflict serializability. Swapping is possible only if S1 and S2 are logically equal. Means logically both are equal only it is possible for the swapping. Then the condition S1 is equals to S2, then we are calling as a non-conflict serializability. Coming to the conflict serializability means S1 is not equals to S2. S1 schedule is not equals to S2 schedule. We are calling as a conflict serializability. Means under the T1 transaction, when we are reading and writing, two operations will be there. Under the T2 transaction also, we are having as a reading and writing operation. When we are swapping, here the functions will be, the instructions will be different. Means that is the purpose. S1 is not equals to S2. Now, when you are going for the non-conflict serializability, under the non-conflict serializability, now the schedule is a S1. Under the schedule S1, two operations will be there. Under the T1, we are having as a read operation. Under T2, we are having as a read operation. This the read operation we can call as a instructor. Two instructions or two operations will be there on T1 and T2. Coming to the schedule 2, under the schedule 2 also we are having T1 transaction read operation. Under T2 also read operation will be there. Now when we are swapping also we are getting as a similar. Under the T1 read will be there. Under the S1 schedule T1 read operation will be there. Under the S1 schedule, under T1 transaction read operation will be there. Under the S2 schedule, T1 transaction read operation will be there. Means similar exiting. Even though when we are swapping the operations or instructions also, under the transaction we are getting as a similar operation, then we are calling as a non-conflict serializability. Non-conflict, when we are swapping means even the T1 also read will be there, T2 also read will be there under the S1 schedule. Coming to the S2 schedule also we are having as a read and read will be there. Means when we are swapping under the T1, it is executing the second stage of the instruction. Under the T2, it is executing the first stage of the instruction. Under the S1 schedule, it is not, under the T2, it is not executing the first stage of the instruction. Coming to under the S2 schedule, it is executing the first stage of the T2 transaction. Then only we can call as a non-conflict serializability. Conflict serializability means both the schedules will be not the equals. When we are swapping the transaction, when we are swapping the schedules under the transaction, under the T1 transaction is one operation will be there. Under the T2 transaction another operation will be there. Under T1 and T2 different operations is existing, operations or instructions is existing. Under the S2 schedule T1 and T2, under the T1 and T2, under the T1 transaction read operation is existing. When you are comparing to the S1 under the S1 schedule, here the read will be there. When you are coming to, it is going to the read, it is coming to the write, it is existing. Means the first stage will be there, here the second stage will be there. Means when we are, means even though if you are swapping also S1 is not equals to S2, then only we can call as a complex serializability. Thank you.